Hi, and now we will be solving practice C, that's on page number 49. And as you can see, just one second, let me share the screen. Um, yeah, yeah. A car accelerates uniformly. Is it nice? Hmm. A car accelerates uniformly from rest to a speed 6.6 meter per second in 6.5 seconds. Find the distance the car traveled during this time. Okay. So this is a very easy question. And first you figure out the values given there. A car accelerates from uniformly from rest. Okay, so but before that, let me write the page number and practice question. This is practice C, page 49. Okay. Question number, a car accelerates uniformly from rest. So it's having a uniform acceleration. Okay. It accelerates from rest. So that means your initial velocity is 0 to a speed 6.6 meter per second. So from rest, it reached a speed 6.6 meter per second. So your final velocity, Vf, is 6.6 meter per second. Find the distance the car traveled during this time. Oh, yeah, in 6.6 meter per second, in 6.5 seconds. So delta t also given 6.5 second, and they are asking you the distance traveled, delta x. Put a question mark. Now you look at the equations given here. If you look at the first equation, delta x is equal to half into vi plus vf in delta t. And look at the values given there. You need to find out delta x, so that term is there. If you look at vi, va is there, vf is there, delta t is there. So the first equation is going to be this is your equation. And again here, if va is 0, that equation will reduce to what? Delta x will be equal to half into vf delta t. Okay. Why? Because vi is 0 here. Okay. Anyway, I will start writing with the equation. So the equation you are going to use is delta x is equal to half into vi plus vf into delta t. Since your vi is 0, since you start from rest, your equation will reduce to delta x is equal to half into vf into delta t. This is such a simple equation problem. Everything is given directly. So half into your vf value is 6.6 times delta t is 6.5 second. So just take the product. So 6.6 times 6.5 multiplied by half. Okay. So answer is 21.45. And you look at the number of significant figures there in the question. You have only two significant figures. So 21.45 you cannot. So if this is the distance, if you reduce this to two significant figures, so your final answer is going to be 21 meters. Okay. Now you may look at question number 2. In question number 2, when Maggie applies the brakes of her car, the car slows uniformly from 15 meter per second to 0 meter per second in 2.5 seconds. So look, what are the values given there? In question number 2, when Maggie applies the brakes, of course, when you brake, the car will slow down. The car slows uniformly from 15 meter per second. So your initial velocity is 15.0. So here you have three significant figures, okay? To 0.0 meter per second. So your final velocity, that means the car comes to rest, okay? So here you have only two significant figures, 0.0 meter per second in 2.50 seconds. So your delta t is 2.50 seconds. How many meters before a stop sign she must apply her brake in order to stop at the sign? So actually, like in this question, they are asking, your initial velocity, final velocity, final velocity is 0, and it is taking 2.5 seconds to stop. Okay, so how many meters before she should apply brakes so that she can stop the car before that, before the stop sign? That's the question. So simply they're asking delta x, okay, the distance traveled during that braking time. Once you apply the brake, the cars won't stop all of a sudden. It will travel a certain distance. So that distance is actually called the stopping distance, okay, stopping distance. So delta x, they're asking the distance traveled during the period of that braking. Okay, so this one we can directly use the equation. Delta x is half into vi plus vf into delta t. So that's our equation. Delta x is equal to half into vi plus vf into delta t. So since here vf is 0, this will reduce to delta x is equal to half into your vi is 15.0 meter per second. vf is 0, so no need to write that one. Okay, anyway, I'll write 0 times delta t is 2.50 seconds. So this is going to be 15 by 2 times 2.5. So 15 by 2 is 7.5, 7.5 times 2.50. So your answer is going to be 18.75, okay, 18.75. 18.75 meters. And you can round this to 18.8 meters. So that's the answer for number 2. And now I'll do number 3. So 18.8 meters. So you have to apply brake at least 18.8 meters before that stop sign. Okay, or you can say simply 19 meters. Then only the car will be, you'll be able to stop the car. Okay. Question number 3. A driver in a car. Okay, we'll erase this. A driver in a car traveling at a speed 21.8 meter per second sees a cat 101 meter away on the road. How long will it take for the car to accelerate uniformly to a stop in exactly 99 meters? So the question is, once again, we can read a car traveling at 21.8 meter per second. So your initial velocity is 21.8 meter per second. He sees a cat 101 meter away on the road. How long will it take for the car to accelerate to a stop in 99 meters? So you need to stop in 99 meters. So delta x is not 101, it's 99. Why? Because the cat is 101 meter in front of you. So if you are going to stop at 101 meter, the car will just hit the cat. So you need to stop in front of the cat. So that's why they put the delta x to be what? 99 meters. And they're asking how long. So you need to find out delta t. And here one value is unknown, but it is clear from the question. You are going to stop. So what's going to be your final velocity? Your final velocity is going to be 0. Okay, since the car is going to stop. Okay. Now again, so which equation you're going to use? You're going to use the first equation. Okay. So the equation is delta x is equal to half into vi plus vf times delta t. So that is equal to half into your vi is 21.8 meter per second plus your vf is 0 times delta t. It's a very easy question. Delta t you don't know. That's the one you need to find out. Okay, delta t. And what's the value of delta x? 99 meters. Okay, so now you can rearrange this equation. So you can cross multiply this 2 and 99. So you can bring 2 to the numerator. So 2 times 99 will be equal to 21.8 meter per second plus 0. You don't want to consider that one, times delta t. So now you have to find out this term delta t. So delta t is going to be 2 times 99 divided by 21.8. So 2 times 99 divided by 21.8. So your answer is going to be 9.08 seconds. So in this question, you can see the least number of significant figure is 2. So you can round this to 9.08. You can round to 9.1 seconds. 9.1 seconds. Okay, I think that one is clear. Now, the last question from that exercise is okay, question number 4. A car enters the freeway with a speed 6.4 meter per second and accelerates uniformly for 3.2 kilometers in 3.5 minutes. How fast is the car moving after this time? So here they're asking how fast is the car moving after this time. Means they're asking you the final velocity VF. What are the values given here? Question number 4. A car enters a freeway with a speed 6.4 meter per second. So your VI is 6.4 meter per second and accelerates uniformly for 3.2 kilometer. So the delta x is 3.2 kilometer. You can see the velocity is given in meters per second. So the distance is coming in meters. So you have to convert that kilometer to meter. So 3.2 is 3.2 times 10 power 3. That is equal to 3,200 meters. So simply you can say 3.2 times 10 power 3 meters. Okay, because kilo is 10 power 3. And for how many minutes? 3.5 minutes. So your delta t is 3.5 minutes. Again, the time you can see velocity is given meters per second. So the time should be in seconds. So 3.5 times 60, that is going to be 210 seconds. So what's your aim? You're going to find out VF. Okay, so you will write out the equation. The equation is same, the first equation. Delta x is half into VI plus VF times delta t. Okay, so you are looking for VF. You know delta t, so these values you know. Delta x is given, 1 second. Delta x is given, delta t is given, Vi is given. You are only looking for Vf. So you can just rearrange this equation. You can just cross multiply these terms, okay? This 2 and delta x. So this 2 will come to numerator. So 2 times delta x will be equal to Vi plus Vf times delta t, okay? Now you're looking for Vf. So delta t is outside the bracket. So this delta t also you can bring to left hand side. So this will go where? It will go to denominator. Okay. So this will become 2 times delta x divided by delta t is equal to Vi plus Vf. It's simple mathematics. Now everything is simple. So Vf will be equal to how much? 2 times delta x divided by delta t. So now we can just plug the values. So 2 times delta x value is how much? Delta x is 3.2 times 10 power 3 meters divided by delta t is how much? 210 seconds equal to VI plus VF. VI is 6.4 meter per second plus VF. Okay, so when you solve this, 2 times 3 divided by 210. So that is 30.476. So that you can out to 30.5. Okay, so 30.5 meter per second equal to 6.4 meter per second plus VF. So your VF is going to be, which you can just bring the 6.4 to the left hand side. Okay, so I will write it over here. Oh, okay, all right. So your VF is going to be 3.5 meter per second minus 6.4 meter per second. If it's going to be, once again, I lost it, 30.5, sorry, 30.5 meter per second, 30.5 meter per second minus 6.4 meter per second. Okay. So the answer is 24. Okay, 24 meter per second. That's all for today. Thank you for joining me. See you tomorrow. Bye.